Hello, I'm Ronan Nagaraja, and here's my invention. Most prosthetic arms that you could find anywhere are pretty much from these big companies that don't even sell their prosthetic arms, or if so, it's at a very extremely expensive price, and most of them are for research purposes, and the rest are just these lifeless plastic arms that are just used for looks. I wanted to make an arm that is actually possible to be sold and at an affordable price, but has the exact same capability as one of those big expensive companies. I decided to use the movements of muscles to actually move the fingers of a robot arm or prosthetic arm, and this turned out to come very well and pretty much had the exact same results as those of these big companies. After some brainstorming, I decided to use a pressure sensor that determines the amount of contraction from the muscle that actually gives a message to servo motors that I'm using to pull a fishing wire to pull the fingers of a robot. Instead of having the robot arms open and close, it could actually be in any position that you want. Then I have the joints of the fingers. For the main joints, or the biggest joints of the hand, I decided to use a ball joint, which is actually pretty much a 2D ball joint made out of a cylinder and an outer plastic piece. I 3D modeled this in Fusion 360 and then later 3D printed it. Instead of having to force the ball joint to click inside that little joint, I actually made it so that I can place it from the side of the joint and then make a little cap that I made to cover it, and it kind of clicks inside and it creates really good joint movement in the fingers. I decided to use sheet metal because it's extremely easy to use and easy to cut. It's also easy to super glue together and put together. The servo motor that I use is the Smraza SG9093 micro servo motor kit, and the Arduino that I use is an Arduino Uno R3, which is really easy to use. They have their own coding software and their own code that it's easy to tweak and edit, and I made it work pretty well. The thumb movement was extremely hard because I wanted to make it move in a 360 axis. This was a real challenge because the joints that I'm using is only in one axis, so I had to use two of them at two opposite axes to make it able to move on 360 degrees. The way I made the thumb move is that whenever I move the bottom of the thumb, the top of the thumb actually curls in the opposite direction. I did this by using two separate strings. One string is connected straight to the motor and the other is connected straight to the plastic piece, which makes the string not move at all, except whenever you move the bottom part of the thumb, the top part of the thumb gets pulled by the string that is being shortened in length. I created these little brackets at the end of the fingers so that prohibits the fingers from going back and goes only the direction that it's needed. At the back of the fingers, I added an elastic that pretty much pulls the fingers back so that whenever the motor is pulling in the direction that is needed, it doesn't just stay in that position, it is moved back. This specific project was made in the situation of if someone had an amputation on their forearm, with their arm being able to do supination and pronation and move their different elbow joints. But not all people with amputation have it like this. This is why I did some research and planning on the different other types of movements on the arm. As you can see in this, I created a diagram that shows the planning of if I were to use an elbow joint or pretty much any joint possible to move an extra movement. I used a potentiometer and two metal rods that would be really easy to use and manufacture, and that can be used in any joints possible to have other movements in the arm that might be in need. A way I had to accomplish supination and pronation in the wrist is using a gear system. This gear system is made so that when the arm is extended, it is towards the object or away from the person, and when the arm is under 90 degrees, it is towards the person. This gear system allows the robot to naturally have this motion. Since this is only mechanical parts and no electrical parts, it's really easy to get the hang of after some practice. Here you can see the little ports that I added these breadboard wires to. I have the 5-volt input, the ground input, and the analog input, as well as a signal input that all goes towards the servo motors that are pretty high torque and can pull the fingers. Over here you can see the breadboard. It's a small breadboard that I actually connect everything through. I have a little foam piece that I put the servo motor in with the little plexiglass piece, and I have the full hands that pretty much is made out of sheet metal and plastic that I have fishing wire connected through the thumb, stopping here and connected straight to here with no moving parts. I created these little loops and these little hooks over here so that they go through. There's some stuff that I would change with this project. Some are that the fingers don't go as far as I would want them to. I would fix that with using different motors that could go more degrees, or I could tweak the code. But I would definitely do some project like that again, and I learned a lot from this project, and yes.